Hi, welcome to CSEC Chemistry at Edu Solutions Institute. So today's lesson, we are continuing with reaction or bonding or the types of reactions in chemistry. Now we're focusing this lesson on the reactivity series. Now the importance of the reactivity series is very good for creating reactions to know if products will be formed or products will not be formed. So what we're going to look at today is what is the reactivity series. Now, the reactivity series, in terms of metals, place them in terms of their reactivity based on how vigorously they react with water or with dilute acids. So therefore, when we react these metals with water and dilute acids, how fast they do react? What type of reaction is it? Does it is a calm reaction? It's a violent reaction? And then we use that to actually rank these metals in terms of their reactivity. So based on that, we have that potassium is one of the most reactive element there is. And then gold is one of the least reactive metals that we have. So going up this chain, we have the increase in the reactivity, right? So the top ones are very reactive, then the middle ones are not that quite reactive. The bottom ones are not reactive, and no reaction between silver or gold under conditions of water and dilute acids. But they do react with other things, just not very reactive, right? Here we have just a breakdown of what happens between these metals and mixing with water. So the top three metals, when they mix with water, they give the hydroxide of these metals as well as hydrogen gas, right? The middle section, calcium, magnesium, they do the same. They give you the oxide plus water. And it continues where the middle part from aluminum to tin, they give you not an hydroxide, but they give you the oxide itself, right? And this is with cold water. Well, this is with warm water, sorry. So cold water, they will not be able to react with cold water, but they will react with warm water, right? These ones up here, they would react with cold water. The top three would be very reactive with cold water. These two would be a little bit reactive with cold water. These do not react with cold water. And then the bottom three, we have no reactions with water or with steam. All right. Now, what's the importance of the periodic or the reactivity series? This is where we look at the displacement reaction. So remember we talked previously on the types of reaction. Now, one of the reaction is called a single displacement reaction. And this is where one metal is going to displace another metal to create a new compound, right? Now, the importance of the reactivity series that we focus at this level is to say, how do we know when a metal will displace another metal, right? So if we look at this reaction here between aluminum and iron oxide, the two metals are aluminum and iron is mixed with oxygen. So therefore, in order for this to be a reaction, aluminum has to be more reactive than iron for it to take away the oxide from it. And here in the reactivity series, we see that aluminum is higher in reaction than the iron. So therefore, we will get a displacement reaction. Right? If we look at this one now, where it is copper sulfate and iron, right? So the iron and the copper. So iron needs to be more reactive than copper in order for this reaction to happen. Based on our series, iron is more reactive than copper, hence we will get a reaction. So the iron displaces the copper and takes away the SO4, and the copper is left to be by itself. Right? So based on that logic, what I want you to do is to look at this, take a moment, pause this video, and see if you can get these right. Between lead and iron sulfate, will there be a displacement happen? Will there be a reaction that happens? Based on this, we see that no, because lead is less reactive than iron, so it cannot displace iron from the sulfate. If we look at lead and copper, lead is more reactive than copper, so therefore it will displace the copper from the sulfate. Iron is less reactive than zinc, so iron cannot displace zinc from its sulfate. And tin is more reactive than copper, hence tin will take away the sulfate from the copper. So this is the very important reason for your reactivity series, right? And we will look at this in depth going forward with all types of reactions, right? So it's important to remember the reactivity series, right? You can use any mnemonics to remember any poem to remember the order for these reactions because it's going to be important to go forward in writing equations, knowing if there will be a reaction or not. Thank you for watching. Hope you understand and made this clear on what the reactive series is and its importance in chemistry. I'll see you next week where we continue to learn more on our CSEC syllabus.